Students, the next concept we're learning is standard normal variate. Now, what's the difference between a normal distribution and a standard normal distribution? Majorly, students, there are two differences between a normal distribution as well as a standard normal distribution. First is, we said in normal distribution that mean, median and mode, all these are equal. Definitely the same rule stands even in standard normal variate distribution, that is mean, median and mode all are equal, but in standard normal distribution mean is equal to median is equal to mode are all equal to 0. That means the value of mean, median and mode is equal to 0 in a standard normal variate. Next important point to remember is of the standard deviation, SD, or we also call it as sigma symbolically. The sigma value for a standard normal variate is always equal to 1. And therefore, students, very importantly, the probability density function for a standard normal variate will change a little bit. How will it change? Let us see. Normally, what is the probability density function? The probability density function for a normal distribution is P of x is equal to 1 by sigma square root 2 pi into e to the power minus half, open the bracket, x minus mu divided by sigma the whole square. But now, I already told you that mean is always 0 for a standard normal variate, as well sigma is always equal to 1 even here. That means for a standard normal variate or for standard normal distribution, P of x will be equal to 1 by sigma is anyways the value is 1. So, only root 2 pi remains here, e to the power minus half, and here x minus 0, x itself remains, sigma is also 1. So, what remains is only x square, and x square into 1 is nothing but x square. That means we can only write P of x is equal to 1 by square root 2 pi e to the power minus x square by 2. This is the probability density function for a standard normal distribution. And lastly, students, for the sums that we are going to do, very importantly, as we had PMF for various distributions under discrete probability distribution, here from the PDF, we have something called the SNV, that is the standard normal variate. And standard normal variate for normal distribution is Z is equal to x minus mu divided by sigma, where mu is the mean, sigma is standard deviation, and this one follows normal distribution. And don't forget to write the parameters here for the standard normal variate, which is mean, mu as well as sigma square, that is the variance. This is a very important formula, students. For the normal distribution sums, we will be using this formula. Once again, recall the formula. Z is equal to x minus mu divided by sigma, follows normal distribution, and write the parameters mu, sigma square. Now, we will see certain problems of normal distribution. So, students, now that we have learned all the properties as well as the area properties of normal distribution and standard normal variate, let us look at a few sums. Firstly, in the bell-shaped curve, how do we find the areas of a normal curve? Now, if x is a normal variate with mean 64 and variance 144, find P of x greater than or equal to 67, probability of the value between 60 and 66 as well as the probability of x less than 62. If such a question comes, students, the first criteria or the first thing what we would write is x is a normal variate. Okay, that means x follows normal distribution with mu and sigma square, the normal parameters of it. Mu is mean, which is a 64, and sigma square is 144 is the square root, which is 12, that means 12 square. Now, we need to write the standard normal variate here. So, standard normal variate, students, would be z is equal to x minus mu divided by sigma, and this follows normal distribution with the parameters 0 and 1. Firstly, let us look into the question and write the standard normal variate based on this particular question. So, it is z is equal to x minus, what is mu given to us? Mean is mu, which is 64. So, I will write 64 divided by, what is the value of sigma that is given to us? Sigma is not given. Variance is given 144, students. So, variance is 144. So, standard deviation is equal to square root of 144, that is 12. So, I will write it here, sigma is 12. Once I have got z value, now it is easier, students, to find out whatever is given to us. First question given to us is probability of x greater than equal to 67. So, how do we find this out? Is equal to, this is how we will write it, P of bracket. First, wherever there is x, we will fill it with the normal variate function, that is, we will write x minus the normal variate. What is it? X minus mu by sigma, that is x minus 64 divided by 12. Next, write the same symbol, greater than equal to. Then write, wherever there is x, write 67 minus 64 divided by sigma, which is 12. Next step, probability of, what is x minus 64 by 12? Look into the previous part here. X minus 64 by 12 is nothing but z, or the standard normal variate. So, write it there, z greater than equal to, simplify this, students, 67 minus 64 is equal to 3. 3 divided by 12. How much are you getting it? You should get 3 by 12 as 0.25. Now, once we have finished so much, very important and crucial part, students. After this, you need to plot this in the bell-shaped curve graph. Let us see the values here. This is minus infinity, this is plus infinity, this is the mean, and mean for a standard normal variate is 0. Okay. 0.25. Where did this come in the bell-shaped curve? This is 0. These all are minus values. These all are plus values. Here it is plus 0.25. 0 is here. 0.25, that means it will come somewhere here. This is 0.25, this line. Now, they have told us greater than 0.25, greater than, remember, greater than is always on the right side, less than is always on the left side. So, greater than 0.25 in the sense, they are asking us to find out this particular area. They are asking us to find this particular area greater than 0.25 up to plus infinity. Therefore, area from 0.25 to plus infinity is, what we need to do is, students, we need to look into the area under normal distribution graph tables, which is there in your statistical tables book or in your stats textbooks. At the end, we have area under the normal curve. We have the z values there. Remember, students, always in your statistical tables, the values are given from negative or positive numbers, but they are given from this part to the plus infinity part and not to the minus infinity part. So you can find now 0.25 to plus infinity in your statistical normal distribution tables. What is the value? 0.25 to infinity. Quickly, I assume you have got it by now. So you should get the value to be 0.4013. And this is the answer for the first part, that is greater than, we had greater than 67 minus 64 divided by 12, greater than 0.25, and for greater than 0.25, this is how we find the area, and this is the answer. Now students, if this was the answer for the first part, let us see how we go about the second part of the question. The second part of the question, students, says P of 60 less than equal to x less than equal to 66. How do we solve this now? Let us substitute the standard normal variate. Remember, students, wherever there is a number, there in the standard normal variate, wherever there is x, you substitute this value. If you do not have a value, for example here, keep it as x itself. Mu, whenever it is there, substitute 64, and sigma, substitute the standard deviation value, that is 144 square root 12. So let us do it. P of 60, so this is the second one that we are doing. P of 60 minus 64 divided by 12 less than equal to x minus 64 divided by 12 less than equal to 66 minus 64 divided by 12. Close the bracket. Probability of this will be minus 2 by 12. How much is minus 2 by 12, students? You should get it minus 0.33. Don't forget the sign here, the negative sign. You have to write it always. Less than equal to, this is z, less than equal to 66 minus 64 is 2. 2 by 12. How much are you getting? 2 by 12. In your calculators, you should get it 0.17. So students, now, firstly, even before writing area from which part to which part, let us first write or draw the graph, the bell-shaped curve. So here is the bell-shaped curve. Mu is equal to 0, minus infinity, plus infinity. These are the points of inflections here. The points are not touching at the end. Mu minus sigma, mu plus sigma. Let us see now what is asked. Minus 0.33. Where is it? Here. Minus 0.33. This part. Okay. Plus 0.17. Plus is this side. That means somewhere here. 0.17. They are asking that z value falls between these 2 points. That means z value falls between these 2 points. Okay. So from where to where we have to find the area? We have to find the area from minus 0.33 to 0.17. From minus 0.33 to 0.17 is what the area we have to find out. But can we directly find out in the standard distribution tables, in the normal tables? Definitely not. I told you in the normal tables always the areas will be given either negative or positive number, but from that to the right hand side, that is towards the plus infinity side. So what we can do is, students, understand carefully, very easy, but just follow it. You need to find first from this point till here, from minus 0.33 till here, we will find the entire area. This much area we will find out. Next what we will do is, we will find out this area, 0.17 to this point, this entire area. Then what we can do? It's easy. This entire area we have found out. This area we have found out. When I minus this particular area with this smaller area, I will get the smaller area and the required area's answer. That means I will have to do to find out this area is nothing but area from minus 0.33 to plus infinity minus area from 0.17 to plus infinity. I should find the area from minus 0.33 to plus infinity minus the area from 0.17 to plus infinity. Quickly look into your standard normal distribution tables, Z tables, and see minus 0.33 to plus infinity. Be careful, see the minus 0.33 area, do not see the plus values, it's minus 0.33 to plus infinity. How much is it? It should be 0.6293 minus, how much is this area from 0.17 to plus infinity? Yes, it should be 0.4325. Minus both the areas, students, 0.6293 minus 4325, you will get 0. How much is it? 1968. This is the area required, or this is the answer required for the probability of the area between these two numbers, and this is the answer. Similarly, we will do another one, that is the last question which is given, P of x less than 62. So the last one, that is P of x less than 62. Now you have to be a little quick, students, to understand at least the first part of it up to the graph. You need to know how to do it. So it is P of x minus mu, that is 64, divided by sigma is 12. Now it is less than sign, so put it less than. Now x place is occupied by 62 minus 64 divided by 12. So this is P of x minus 64 divided by 12. This is Z, the standard normal variate, less than 62 minus 64 is minus 2 divided by 12. Minus 2 divided by 12, students, we get 0.17. Don't forget the minus sign. Now, the graph, or the the curve plays a very important role. Let us see how to plot it. The bell-shaped curve, minus infinity, plus infinity, mark where is minus 0.17. Here, minus 0.17, this is the point 0 here. Understand, students, what are they telling here? They are telling less than minus 0.17, less than in the sense still more lesser value, down you have to come. That means they are asking us to find out this particular area. They are asking us to find out this area Z less than minus 0.17. Till now in both the questions it was greater than, and this was in between, whereas this is less than now. So be very careful. Less than shading always comes to the left hand side. How will we find this area, students? Now we do not have in our standard normal tables to find area from minus 0.17 to minus infinity. Don't get confused here. Some of you might directly see, okay, minus 0.17, you will see into your Z distribution table of Z tables, and you will see minus 0.7 to infinity, you will write down the value. No, we do not have the value minus 0.17 to minus infinity. What we have in our books is minus 0.17 to plus infinity, not minus. So don't get confused. But still, can we find this out? Yes, definitely we can. What we'll do is, first we will consider this full area. How much is the full area? I told you area under the graph or area under the normal curve, entire area is 1. So we will consider this entire area and we will find this area minus 0.17 to plus infinity. And then we will, this entire area, we will minus it with this one and find the answer. So firstly, let us write here, we have to find area from minus infinity to minus 0.17 from here to here. But we do not have it. So what we do? It is equal to area from minus infinity to plus infinity, this full area, minus area from minus 0.17 to plus infinity. This is how we will do it. What's the full area? Minus infinity to plus infinity. Area under the normal curve, 1. Minus area from minus 0.17. Search in the Z tables, where does minus 0.17 come? Minus 0.17, and see the area under the normal curve. It should be how much? Yes, it is 0.5675. Now find the final answer. 1 minus 0.5675 should be equal to 0.4325. And this is the way, students, 3 different ways of finding out when it is greater than, when it is in between, and when it is in less than. And this is how we will solve even the future problems of normal distribution. Practice more and more so that you can work it out faster and you can score well in your exam.